This is the question number 25 of GATE 2014 Metallurgical Engineering. The question states that which one of the following signals from a specimen is used in a scanning electron microscope to get quantitative elemental analysis? Option A, secondary electron. Option B, backscattered electron. Option C, X-rays. And option D, transmitted electrons. Now let us solve this question. When an incident beam interacts with the specimen, it generates several signals like secondary electrons, continuous X-ray, OJ electrons, backscatter electron, characteristic X-ray. And if the sample is thin enough, the incident electron beam may also be transmitted, and there also, because of the elastic and inelastic scattering, different signal will develop. So the bottom side of this diagram is we study in TM, and the top side we study in ACM. So now we'll discuss about the different kind of signals that are being generated in the ACM. So now these signals carry several informations from the specimen. Now what kind of information they are carrying, that depends on how the signals are getting generated. So for that we need to look into the atomic level, that how the electron beam is actually interacting with the atom, and how this kind of signals are getting generated. So now this is the incident electron beam. So when it is interacting with the atom, it has two options, like either it can interact with the nucleus or it can interact with the electron. So now when this incident electron is interacting with the nucleus, so because of the higher positive charge of the nucleus, the incident electron beam changes its trajectory and it comes out as a backscatter electron. Now as this scattering is happening because of the elastic scattering, so the energy of the backscatter electron is almost nearly equal to the beam electron. And this changes in trajectory totally depends on the Z number of the nucleus. What is the atomic number of the nucleus? So that is the reason that backscatter electron basically carries the Z contrast information. So this will carry Z contrast information or atomic contrast. Now if this incident electron beam is interacting with the electrons, so it can knock out electron from the inner shell of the atoms, and this knocked out electron will came out of the sample of the atom as a secondary electron. So as this process is happening because of the inelastic scattering, the secondary electrons has a very less energy, and as it has very less amount of energy, the secondary electron can only come out from a very shallow or small depth of the specimen. So as it is basically coming out from the very small depth of the specimen, so it will carry the topographical contrast. It will carry topographical contrast. Now to fill up this vacant site, the electron will jump from the outer shell to this inner shell, and the difference in the energy between these two cells will emit as a characteristic radiation. So this energy difference between these two cells will emit as a characteristic X-ray radiation. As this characteristic X-ray radiation is totally a function of your atom, what kind of atom is this there, and also the intensity of the characteristic radiations will depends on the concentration of that element on the specimen. Now another signal is OJ electrons. So when this characteristic radiation also may cause the knocking out of loosely bound electrons from the atoms, and these electrons will come out as a OJ electron. These electrons also has a very less energy, so that is the region it can only come out from the very near to the surface region. So it also carries composition contrast, and it is a very high resolution contrast. And the characteristic radiation also, it will also give you the elemental or composition contrast. and intensity will give you the concentration. So now let's back to the questions. So the question was which of the following signals is used in a scanning electron microscope to get a quantitative elemental analysis. So as we have seen that it will give the topographical contrast, backscatter will give us the Z contrast, and X-rays or characteristic X-rays will give us the elemental contrast or composition contrast, and also the concentration of that element. So the correct answer will be option C, X-ray.